chemistry which deals with optical properties, or which deals with the study of optical properties of a particular substance, is known as stereochemistry. First one is optical isomers. What we understood by this particular word? Optical isomers. So the compounds having similar physical and chemical properties, but differing only in their behavior towards polarized light, is known as optical isomers. And this phenomenon is known as optical isomerism. Understood it properly, they have same physical and chemical properties, but their behavior towards plain polarized light is totally different. And because of that, they are known as optical isomers, not normal isomers. Here we have to use the word optical isomer. So what is the meaning of this optical? Optical means it relates with light, how it behaves when the light imparted on it. Likewise, it is known as optical isomers or optical isomerism. Okay? Here, what we can understood it by. So, the two different types of optical isomers are there. Number one is dextro-rotative. Optical isomers are of two types. One is dextro-rotatory, second one is levo-rotatory. But third type is also there, and even I should say it has four different parts: dextro, levo, racemic, and meso. But meso will not be shown by each and every compound, so we will consider here three: dextro-rotatory, levo-rotatory, racemic mixture, etc. So here, dextro-rotatory means it rotates the plane polarized light towards right hand side. Levo means it rotates the plane polarized light towards left hand side. And racemic, it's a mixture of both of this. Half portion is a dextro, half portion is a levo. So the plane polarized light will not be rotated towards either left or towards either right. It remains in the same position, so it is known as racemic mixture. It remains neutral. Okay? For an example, lactic acid. For an example, tartaric acid. We have another example of malic acid, etc. Such kind of compounds are optical isomers in nature. The next topic we will have is enantiomers. So what is the meaning of enantiomers? Enantiomers are the compounds that are non-superimposable but mirror images of each other. As you can see it in the image, they can't be superimposed on each other, but they can be mirrorized on each other. That means they are mirror images of each other. Right? Such kind of compounds are known as enantiomers. Lactic acid, tartaric acid. We can take other examples also here, which are enantiomers. Let's observe it through the example here. We have the example of lactic acid. As you can see, the middle part contains carbon. On the upper side, it has the functional group COOH. Right hand side contains atom H. Below it contains CH3 methyl group. On the left hand side, it has OH. Now, on the exact opposite side of the mirror, you have the same one, lactic acid, the same compound. Upper side contains COOH, lower side has a group CH3. Now the change occurs where? On the left and on the right hand side. Here it has OH, here it has H. On the exact opposite side, H and OH. The position of H and OH is just been exchanged here, and they are enantiomers of each other. They are non-superimposable but mirror images of each other. As you can see here, lactic acid are non-superimposable but mirror images of each other. You can see it in our image also, that the structure is totally non-superimposable, but it is a mirror images of each other. Even our hands are non-superimposable on each other, but they are mirror images of each other. Right? They are the best examples of enantiomers. You have to understand it practically, that how they are widely used and why they are actually widely used in food industry. Right? Because of that, such kind of behavior towards light, they are widely used in food industry. Now, let's observe the properties of the enantiomers. Enantiomers have some same physical and chemical properties, so they can be separated by the fractional distillation only. Okay? They have each and everything similar, chemical properties, physical properties, everything, but by fractional distillation they can be separated. Likewise, the enantiomers are differ only in their behavior towards plain polarized light. If one is dextrorotatory, then the other form is levorotatory, and even it has racemic mixture, then also we can obtain it. So we can differentiate the enantiomers, that such kind of compounds which are the mirror image but non-superimposable on each other, right? And they are enantiomers. Now, enantiomers have same rate of reaction with chiral reagent but have same rate of reaction with achiral reagent also. So, such kind of property will be observed. And the last one, they have different biological properties. So, using certain biological differentiation technique, we can differ the enantiomers. We can differ the forms of enantiomers, like D-rotated or D-lactic acid and L-lactic acid can be separated using certain biological differentiation method or separation method, right? We can define, or we can have a racemic mixture also that it will not pass, or likewise. So this is how we can use the enantiomers and how we can identify the enantiomers in our day-to-day experiments. Now, the next topic is diastereomers. What are these diastereomers actually? So diastereomers are the optical isomers which are neither mirror images nor superimposable to each other. Okay? The optical isomers which are not mirror images of each other, non-superimposable to each other, are known as diastereomers. Now, the diastereomers have different chemical, different physical properties. Right? We can take the example, and even they can be easily separated using any physical method. Here, the example of the stereoisomers of 3-chlorobutane 2-ol is given. Now, as you can see it here, we have 1, 2, 3 and 4. 4 different structures of the compound 3-chloro-2-ol, 3-chlorobutane 2-ol is given. Now, if you observe in the image, the first one and the third one, if you can observe it clearly, they are mirror images of each other but not superimposable, as you can see it here, right? 1 and 2, they are mirror images but not superimposable. Now 3 and 4, similar way, right? But 1 and 3 and 2 and 4 are different. They are the pairs of diasteromers. Okay? Try to understand it properly. Now, next point is plain polarized light. What we understood by this? So the polarized light waves are the type of light waves in which the vibrations occurs. The light waves generally moves in a single direction is known as plain polarized light. Now the process of transforming the unpolarized light or non-polarized light to the polarized light is known as polarization. And for that we will use different kinds of compounds like polarizers that we will see in our next session, that what are the polarizers actually. Thank you everyone.